do you mean by that one? So if you have 4 moles of H2, so the ratio will be based on the balance equation. So ano ang ratio natin? What would be our ratio? The ratio is 2 is to 1 is to 2. So for every 2 hydrogen, there is 1 oxygen used. For every 2 hydrogen, there produces 2 moles of water. So if given is 4 moles of H2, how many moles of water is going to be produced? So this is how we're going to use it. So 4 moles of H2 must be multiplied by the ratio. So again, anong ratio natin? So for every 1 mole, and for every 2 moles of water, there are 2 moles of hydrogen gas. So 2 is to 2. So we have to use 2 moles of water over 2 moles of hydrogen gas. So we have to cancel out the unit for the 2 moles. Then 2 times 4 is 8. 8 divided by 2 is 4. Then the answer would be 4 moles of H2O. So which means for every 4 moles of hydrogen gas that you're going to produce, you can produce 4 moles of water. But if you're given, for example, 5 moles of oxygen, how many hydrogen gas must be used? Okay, how many grams? So what moles are the given earlier? So what if we're dealing with grams? So for every 1 mole, of oxygen, there is 32 grams. Okay, so which means based on our mole ratio, for every 1 mole of oxygen also, we are going to use at least 2 moles of hydrogen. Now, let's compute. So if you have 5 moles of oxygen, then we have to divide this one. So based on the mole ratio, 1 mole of oxygen for every 2 moles of hydrogen. Then cancel the moles. Then you're going to get 10 moles. 10 moles of H2. However, we're not yet finished because we need to check the mass like this. Okay. For the mass of the hydrogen, for every 1 mole of hydrogen gas or H2, there are 2 grams. Okay. Now, if you're given 10 moles of H2, then based on the mole ratio for every 1 mole of H2 is 2 grams of H2. So therefore, 10 moles times 2 grams is equal to 20 divided by 1. Then we're going to have a total of 20 grams of H2. So which means for every 5 moles of oxygen that is going to be used in the equation, we're going to utilize 20 grams of H2 to form water. So that's how you use your ating mole ratio. Questions so far? Questions? Okay, let's proceed. Now, if you're going to ask this question, if you're going to be asked this question, if 4.61 grams of lead iodide was isolated from the reaction of lead nitrate and sodium iodide, what will be the calculated amount of sodium iodide that reacted with lead iodide with a molar mass of lead iodide for 461 grams per mole and sodium iodide is 150 grams per mole? What's the first thing that we need to establish? If you're given this kind of question, what's the first thing that you need to establish? Anyone? Ano kayang una natin kailangan gawin? What's the first step that we need to do? If you're given this kinds of question, okay, you have to make first an equation to balance it, which means identify the product and the reactant. So PB2 was isolated. So therefore, this is a product and the reaction is lead nitrate and sodium iodide. So this is now your reactants. Reactants. And this is now your product. Now let's try to write. So you have lead iodide, lead nitrate, and plus sodium iodide yields lead iodide. But we are missing one equation, and that would be what you call yung sodium nitrate. Now, what type of chemical reaction is this? What type of chemical reaction? Is it synthesis, analysis, uh, single displacement, or double displacement? Okay, this is what you call double displacement. Now, my question here, is this the balance equation? Okay, not yet. Okay, not yet. Now, we want to balance this first. Now, first balance the sodium. So, balance is sodium, but iodide is not. So, this is 2. So, we have to multiply it by 2. So, sodium iodide must be multiplied by 2. Okay. Now, since there's 2 sodium here, then 2 iodine here, iodine is balanced, but sodium is not. Then multiply the sodium nitrate by 2, and therefore, we will now have 2 nitrates and 1 sodium. But since we have 2 sodium nitrates here, 1 lead and 1 lead, then the balance equation is 1 is to 2 is to 1 is to 2. Okay? Now, we're not yet finished here. Now, the question here is, what is the final amount of sodium iodide that reacted with your lead iodide? Okay? Now, in this example, the given was 4.61. 4.61 grams of lead iodide. Now, we want to establish now first the moles. So, we want to convert the lead iodide into moles. So, for every 1 mole of lead iodide, there is 461 grams of lead iodide. So, cancel the grams. Then we're going to have an answer of 0.01 moles of lead iodide. Okay, good. Now we have isolated the mole. Next, use the mole ratio. 0.01 mole of lead iodide. Now, converting this one into your mole ratio. So, the given was sodium iodide. So, what's the ratio of your lead iodide to your sodium iodide? So, lead iodide is 1. Then, sodium iodide is 2. So, for every 1 mole of lead iodide, there is 2 moles of sodium iodide. So, cancel the moles. Then, 2 times 0.01 is 0.02 moles of sodium iodide. Now, is this the final answer? Not yet, because we want to convert the 0.02 moles of sodium iodide into grams. So, for every 1 mole of sodium iodide, there is 150 grams of sodium iodide. Then, the total answer would be what? 150 times 0.02, then the answer would be 3.000 grams sodium iodide. So the answer is letter B. Okay? Questions? Kakayanin? Kakayanin, syempre. Kakayanin natin yan. Okay. Can we proceed? Do you have any questions? Can you proceed? Okay, good. Kaya pa po. Kayang-kaya yan. Let's go. Now, limiting and excess reactants. Now, for the limiting reactant, these are reactants that are fully consumed in the reaction. So, which means all of the reactants, like for example, A plus B, if A is fully consumed in the reaction and B has an excess, then A is your limiting reactant. And excess reactant, these are reactant that is left unreacted when the limiting is consumed. Now, let me give you an analogy on this one. For example, so, for example, for every one car body, you will create 1 car. Okay? But you will need 4 tires to create 1 car. Okay? So if you want to make a car, you need a car body and a tire. So technically, this is an example that we need to establish. If you have 1,500 car bodies and 4,000 tires. How do we know or how many cars can we produce? Okay. So for every one car is equal to one car body. So 1,500 car bodies must be multiplied based on the ratio that we established earlier. Ako nawala. Okay, ulit. Nawala. So 1 CB is equal to 1 car. 4 tires is equal to 1 car. So if you have 1,500, so if you have 1,500 CB, we want to get the total number of cars for every one car. We have one car body. So therefore, we're going to produce a total of 1,500 cars. Okay? But if you have 4,000 tires, for example, then we want to compute first for the ratio. Then for every one car, you will needing 4 tires. So which means you will create 1,000 cars. Now my question is, who is the limiting, who is the excess? So with the car bodies, you created 1,500 cars, but with the 4 tires, you only created 1,000. So therefore, the 4,000 tires are your limiting. Why? Since all of the tires will be consumed versus the 1,500 cars, there will be an excess of 500 cars in production. And therefore, this is now your excess. Okay? So the limiting reagent is 1,000 cars. Since we have 4,000 tires that we need to establish divided by 4, 1,000 cars will only be produced. And therefore, if these are fully consumed, then it limited the production of the cars natin. But with the car body of 1,500 car bodies producing 1,500 cars, well, we cannot make a new car. We cannot make a new car unless tires are added. Okay? So which means 1 CB plus 40 yields 1 car. Okay? So this is how we define that equation. But you cannot produce cars if you have an excess, since this is limited. Okay? Now, to give you an example, the reaction of hydrogen and oxygen gas to produce water is shown above. Suppose 10 grams of hydrogen are mixed with 32 grams of oxygen. What is the limiting reagent and how many excess grams of the other is left at the end of the reaction? The molar masses of H2 is 2 grams per mole and oxygen is 32 grams per mole. Now, there is a technique that we can use here. The first is write H2 and O2. Now, place the given here. We have 10 grams and place the given here 32 grams. Okay. Now, divide both by the product of number 1. Get the mole ratio. Okay. What's the mole ratio in the equation? We have 2 grams per mole. Okay. And the other H2 is the mass. Okay. The mass, sorry, this is the mass pala. Sorry, this is the mass. And the mole ratio. So, 2. Okay. Nakuha po ba? So this is the given. This is the mass that's based on the given and the ratio. So 2 is to 1. Now for the oxygen, same case. So we're going to get the 32 grams per mole for the molecular weight, then 1 for the mole ratio. Now, divide. 10 divided by 2 divided by 2. This is equivalent to 2.5. Okay? Next, this is 32 divided by 32 divided by 1. This is equivalent to 1. Now, did we get the limiting reagent? Yes. The limiting reagent is the lower value. So this is the lower value. Okay? So since this is the lower value, then we're now going to cross out the first and the second given. Now, how do you get the excess? Now, to get the excess, you have to subtract the excess minus the limiting. So the limiting is 1. So therefore, you're going to have a 1.5 remaining. Now, the 1.5, you have to multiply it back to this value. So we have to multiply it 2 grams per mole and 2. And therefore, 1.5 times 2 is 3 times 2, then it is equivalent to 6 grams 6 grams. And therefore, the answer would be letter C. Okay, did you get it? Okay, that's good. You just need to get this one. I've managed to learn this one with one of the lecturers. This is what you call your banana split method. Banana split method. This is the name that they came up with this one. Okay? Any questions so far? Questions so far? Okay, very good. Now, acids and bases. Now, acids and bases are the ones that we use the concentration, the idea of concentration. And we want to make sure the buffer systems are established in our mind and what's their function on our in chemistry. Now, the Bronsted loaded definitions are known as the acids for proton donors. So the acids donates protons. Okay, those are your H plus. So to give you an emphasis on that one. And bases are proton acceptors. So bases receives the protons, and basically in the equation, when they receive the H plus, they will become the acceptors. Okay. The Lewis definition now are acids that are electron pair acceptors. So which means you don't have a proton, you don't have a hydroxide to begin with, but you have an electron pair that will be accepted. Since based on the Bronsted-Lowry definition, acids are proton donors, then they have to accept electrons, pair of electrons. So they will be reducing yung protons, but they will be accepting electrons in this case for the Lewis definition. And bases are known as electron pair donors, since bases are electron pair donors. So this is the opposite of proton acceptors. Okay, since they are receiving more protons, then they have to reciprocate by donating yung electrons natin. And can we see this one in a single equation? Sometimes, yes, pero not all the time. And Arrhenius acid, not included in this one, these are the Arrhenius acid. Acids and bases dissociate in water and produce your H plus or protons and hydroxides respectively. But in Arrhenius acid definition, this is what they use for that one, the third one. And the concentration of your protons in the aqueous solution is the basis of acidity. So which means the higher the protons, therefore dictates yung acidity. And the lower than 7.0, and this one is basically acidic. Okay? But if your pH is more than 7.0, then this is basically basic. But if your pH is equal to 7, then this is neutral. Okay? So if pH is less than 7.0, then they are considered acidic. But if your pH is more than 7.0, then we consider them as basic. Okay? Now, the strong versus weak acids. Strong acids when combined with weak bases, the final pH level is usually pH is more than 7.0. Sorry, less than 7.0. Okay? And therefore, they are more acidic in nature. So, technically, if the strong base is added with the weak acid, the pH level goes up to more than 7.0, and therefore they are more basic. But if a strong acid plus a strong base is added, then the pH is equal to 7.0, and they are technically neutral. And these are basically what you call now yung ating mga buffers. So later, i-explain ko sa inyo yung definition natin kay buffer. Now, strong acids usually have a counterpart for a strong base. And a strong base always have a counterpart of a conjugate acid. Okay? So, the strong acids are always on the reactants, while conjugates are always on the product side. Okay? Don't be call this one. Don't be confused. conjugate bases and conjugate acids are always on the right side. Okay, they are mostly on the product side natin. So you won't be confused on that one. Strong acids and strong bases are usually on the reactant side because they will be counterparted with your counter conjugates or yung mga conjugate acids and conjugate bases natin. Now, take note of the definition, ha? Bronsted-Lowry, and Lewis definition, and Arrhenius acids. So, Bronsted-Lowry, proton donors, and bases are proton acceptors. Acids are electron pair acceptors, and bases are electron pair donors for Lewis definition. Now, to answer the question, which of the following equations show that water is acting as a conjugate base? Okay? Now, take note. Conjugate base, ha? Conjugate base. So, therefore, we are going to check the water. Now, A and B is not included. Bakit? Now, first of all, is this an acid or a base? Will this donate or will this receive? Will this water accept or donate? What's the partner of your water here? The partner of water is your OH. So did it accept or did it donate or did it receive? This one, based on the Lewis acid, or sorry, based on the Bronsted-Lowry, proton donor. So therefore, H2O here is an acid. Okay? Therefore, this is your conjugate base. But the question here is water acting as a conjugate base. So number one, tanggal na agad. So may reason na tayo kung bakit. Number two, H2O. Again, H2O tayo. Then H3O. Did water donate or received a proton? It received a proton. So therefore, this is a base and this is now your conjugate acid. But water is not acting as a conjugate base. So therefore, tanggal na agad siya. Then letter C. Is water a conjugate base? Again, bases tend to accept protons. Okay? Bases tend to accept protons. Okay? Now, if bases are proton acceptors, and therefore, water are proton donors, then, sino dito yung kailangan nating kunin? Is water a base or an acid? Okay. Water here, sorry, your hydronium ion here, your hydronium ion here is now an acid. Bakit? The acid here is basically donated the proton. And after donating the proton, it became water and therefore, this is a conjugate base. So this is now water. And ano bang hinahanap natin sa question? Water acting as a conjugate base. And therefore, the answer is letter C. Okay? Now, what about letter D? Bakit hindi pwede si letter D? OH minus or hydroxides. The hydroxide here is OH minus. But based on the conjugate here, it accepted a proton. So therefore, if this is a base, then the counterpart here is a conjugate acid since yung H2O natin is nag-accept ng proton galing dito kay H2PO4 to be a conjugate acid. And therefore, letter C is our final answer. Is it clear? Is the statement clear? Okay, basta huwag kayo malilito ha. Ang conjugate base at conjugate acid nasa kanan lagi. So pag sinabi water acting as a conjugate base, unahin nyo na agad yung mga water sa kanan. Okay? Then i-check ninyo if nabawasan nyo na sa kabila or nadagdagan. Like for example, if nabawasan yung proton from left to right, then that's an acid to conjugate base. Kapag nadagdagan yung proton from left to right, then nagiging base siya. So nag-accept siya ng proton. So base and nagiging conjugate acid siya. Okay? Next, which of the following is the Lewis acid that acts as a reactant in the equation? Now, based on the equation, we have water, ammonia, and we have cobalt. Now, which of the following is the Lewis acid? Sabi nila, ang Lewis acid is an electron pair acceptor and bases are electron pair donors. So, sino kaya sa kanila yung acid? Now, water cannot be an acid. Bakit? The water did not try to accept any electron. It actually donated an electron sa part natin sa kanya. And therefore, yung water natin sa part na ito, the water here will not act as an acid. Same kay ammonia. Same kay ammonia. Ammonia is basically donating the electron. Why? If it donated the electron for your ammonia to your cobalt 3 plus, then the cobalt 3 plus basically accepted the electron pair, which means the final answer here is yung cobalt natin. Okay? The cobalt 3 plus. And based on the definition, acids are electron pair acceptors. And based on this one, the cobalt 3 plus is the only factor in our equation that accepted the electron. Did you get the idea? Okay. Questions so far? Okay, let's proceed. Now, neutralization reactions are basically acids plus base. And if you want to neutralize an acid and base, they will form salt and water. Now, the acidic component of your H should be equal to the basic components. So if you want to neutralize an equation, then you have to make sure that the protons and the hydroxides should be equal. And how do you do that one? Now, buffers are substances that prevent drastic change in the pH of a system. Now, the good thing about your buffers is that buffers are the ones that help you to analyze the concentration of the object by adding it slowly but surely. And buffers typically compose of weak acids and bases. Now, is there any way, sir, is there any way po ba para malaman natin na weak ang acid or strong ang acid or weak and base or strong ang base respectively? There's no theory yet to give you that kind of explanation. So, kailangan nyo talaga siyang mabasa. Kailangan nyo siyang medyo makabisado at ma-familiarize kayo with some of them. Okay? Now, because of that, titration is one of the methods that we use that determines the concentration of a substance using a reaction with another substance with a known concentration. The titrant, okay, as we know, the titrants are the known substance. Okay? The titrants are the known substance. So therefore, this is the one that is always been given. But the analyte is the unknown substance. Unknown substance. So if you want to study the concentration of the object, you have to have a titrant and analyte. But how are you going to know if the pH level is correct? Then you're going to use now what you call yung indicator. Now the indicators are, this is the list of indicators. Methyl violet, bromophenol blue, methyl orange, methyl red, litmus, bromothymol, phenolphthalein, and alizarin yellow. Now, these are the colors, color on acidic side, range of pH color, and color on basic side. Now, the question here is, sir, kailangan po ba namin kabisatuhin to? Okay? Kailangan daw ba kabisatuhin? Hindi po. Hindi na kailangan kabisatuhin. Okay? They will always give you the statement. Like, for example, acid A and acid B is added to make a substance or product. Then, phenolphthalein, like for example, phenolphthalein is used to get the pink color on the basic side with a pH level of 8.3 to 10.0. So what would be the equivalence point color after lowering down the pH level up to 8.2? Sasabihin lang naman nilang ganun. So sinasabi talaga nila yun na ito yung ginagawa namin para at least magbago to and all, maging acidic, magiging basic. Yan, kasama yan sa mga statement nila. And para saan ba yung mga titration natin? Para saan pa si titration? The titration for the acid-base titration has what you call the equivalence point because in the equivalence point, on the word equivalence point, you have to get what you call the final point of reference to get the final concentration. Okay? So, based on the idea of concentration, papasok na naman tayo sa formula na C is equal to N over V. C being the concentration, N being the number of moles, and V as the volume. But, for example, if you're given a C1 equals N1 over V1. Therefore, C1, V1 equals N1. Sir, what if meron akong isa pang substance? In the titration, in idea, C1, V1 is equal to C2, V2. Yan yung sinasabi nila. C1, V1 is equal to C2, V2. So, if you have C1 over V1, ay C1, V1 over C2, V2, then this should be equivalent to N1 over N2. So, ayusin natin ng onte. Next slide. So, which means this is C1, V1 equals N1 over C2, V2 over N2 to get the missing value for your titration. So, based on the concentration, we want to make sure that we are going to get the correct number of moles and we have to get the correct number of concentration. Now, given the formula, titration reveals that 8.33 ml of 3 molarity sulfuric acid is required to neutralize the sodium hydroxide in 25 ml of sodium hydroxide solution, as shown in the chemical reaction above. What is the molarity of the sodium hydroxide solution? Okay. Now, given, do we have an initial concentration for sulfuric acid? Yes, meron tayo. So, which means, meron tayong 3 molarity. Do we have a volume for sulfuric acid? Yes, meron po 8.33 ml. Do you have an initial mole based on the mole ratio? Yes, meron tayong 1. Based on mole ratio sa taas, we have H2SO4 and 2 NaOH. Kompleto tayo. Next, do we have the molarity of sodium hydroxide? Wala. So we're going to do this one as C2. Do we have the volume? We have 25 ml. What's the ratio? We have 2. Okay? Now, computing the value, we have 2 times 3 molarity times 8.33 divided by, equals C2 divided by 25 ml. Okay. Now, can we now get the final concentration? Yes, pwede na po. 2 times 3, 6 times 8. Okay. 2 times 3 is 6. 6 times 8.33, 50. Almost 50. So therefore, 50 over 25. Okay? Then 50 over 25 is equal to 2 molarity. Canceling out yung ating units ml, ml. We have no mole ratio. Then the final answer would be 2.0 molarity. Sorry. And therefore, the answer is 2.0. Okay? Questions so far? Okay. Now, which of the following pairs of compounds can act as a buffer solution? Okay. Now, sabi ko nga kanina, what I've said earlier is that, sir, do we have an idea on how to know which is the weak and strong acid? As I've said, you have to familiarize yourself on this one. Now, number one, hydrofluoric acid and sodium fluoride are both weak, respectively, for the acids and bases. And therefore, the first one is considered as a yes. Now, nitric acid, based on its structure, and of course, potassium nitrate, they are basically strong acid and base respectively. And memorizing them would actually give us an idea on that one. But ammonia and ammonium chloride are both weak, since if you want to add ammonium and ammonium chloride in a situation, they are also called as buffers, and therefore, they are going to be weak. And therefore, the first one and third one are the correct answer for this question. Okay, questions? Any questions? Okay, let's proceed. Now, the enthalpy of reactions. Now, the amount of heat in a reaction per mole. Now, the enthalpy is basically the amount of energy that is needed to activate a reaction. Now, the endothermic, when the heat is absorbed, your delta H or your change in enthalpy is positive. Okay? But when heat is produced or it's being released, the change in your enthalpy is negative, and therefore that would be your exothermic. So endothermic heat must be absorbed, and therefore your delta H is positive, and exothermic is heat is produced or released, then your delta, your changes in enthalpy is negative. And the activation energy is the amount of energy needed to be absorbed for the reaction to occur. So you need to have a catalyst, sometimes a catalyst on this one. Sometimes the trigger is temperature, sometimes the trigger is the chemical itself, sometimes the whole reaction is needed to trigger the activation energy. But in most cases, catalyst can be used to create an alternative reaction path with the lower activation energy. Now, what are catalysts? Catalysts are basically the substance that is being used to fasten the reaction but will not be consumed. So therefore, you're going to use it, but it will never disappear. So those are your catalysts. So it speeds up the reaction. Okay? Now, for example, we have delta H, the enthalpy, and we have the time. So if you have the energy of the reactants and your changes in enthalpy becomes negative, then the energy of the product should be what? Would be lower. So based on the idea here, in the production of water, the activation energy is high, but the changes in your enthalpy is lower. So if you want to produce the water on our example here, okay? Now, equilibrium reactions are the ones that apply this idea because reversible reactions can reach a point where the forward and background reactions are equal. So, which means if A and B, if we're going to produce A and B, then producing AB here, once you add A to the reaction to B, then it must be forwarded to AB. But if you're going to add AB in the reaction, you have to make sure that all the reactants is also established, and therefore you have to balance it. It has to have an equilibrium. The Le Chatelier's principle is applicable when a reaction in an equilibrium reaction is disrupted. The reaction will proceed faster in the direction that restores the equilibrium. Now, let me give you an example here. For example, we have a water storage here. Now, both examples would have a specific amount of water here. Okay? So, for example, meron tayong tube dito. Now, what if you increase the amount of water here? So, what happened? Siyempre, it will have to increase the water volume here, and somehow it will affect the pressure gradient here. Now, therefore, if you want to establish equilibrium, once you increase the amount of water in the product, in the reactant side, although it may seem to increase, but after some time to reach the equilibrium, it has to go down. Then to reach the equilibrium, this part has to go up. Then therefore, somehow increasing the product and decreasing the reactant. Therefore, balancing and restoring the equilibrium. Okay? Now, what affects the equilibrium? Equilibrium is affected by temperature, the amount of products and reactants, and we have pressure. Okay. Now, temperature, it depends if exothermic or endothermic. If it absorbs energy, then it's endothermic. If it releases energy, then it's exothermic. Okay? Now, the question here is a colorless hydrogen gas is mixed with purple iodine vapor in a sealed flask. The chemical reaction produces a colorless hydrogen iodide as shown in the equation above. What can be done to in temperature, concentration, and pressure of any of the chemicals in the mixture to increase the formation of purple vapor? Now, The example here is a positive enthalpy. So therefore, this is ex or endo. This is endothermic. Why? As we have stated earlier, if the delta H is positive or the change in enthalpy is positive, then this is endothermic. Okay? Now, since this is endothermic, if you increase the enthalpy of the reaction or if you increase the temperature, then it will go to a forward reaction. Okay? It will forward the reaction. Now, if you want to produce iodine, okay? So if you want to produce iodine, since iodine is in the equation of H2 plus I2 yields H2I, 2HI. If you want to produce iodine, we have to make sure to lower down the temperature so that the reaction will go to the left side of the equation. Therefore, the third one and the fourth one will not be included now on our choices. Next, H2 is basically present. This is colorless hydrogen gas. But if you want to have a more purple vapor, you need to add the reactant. Now, although it may forward the reaction, the idea here is to make sure to produce more iodine gas. And therefore, you have to lower down your hydrogen gas. Since the equilibrium is now going to your reactant, you just need to add the reactant. Therefore, you're going to produce your iodine for a more purple color. And therefore, you don't need to change the pressure. And therefore, the answer would be letter A. Okay? So, decrease the temperature, decrease the hydrogen gas, but you will have to have the same pressure. Okay? Question? Okay, proceeding now with your introduction for organic chemistry. So when you say organic chemistry, these are carbon-based compounds that are basically hydrocarbons in the basic structure. And these are compounds that are mostly used for reactions, especially on organic chemistry, like for carbon and hydrogen, alipatics, we have alkenes, alkanes, alkynes. Now, for the introduction, compounds that contain carbon and hydrogen as the main components but can contain other elements. Okay? There are alkanes, alkenes, and alkynes. Now, let's define first. The alkanes are basically your single bond carbon, CH bonds. And based on the hybridization, they are mostly what you call the sp3 hybridized form. Then if you want to calculate if you want to get the correct alkane formula, the formula for alkane is CN H2N plus 2. So for example, if you have 4 carbons, then the 4 carbons would be C4, then C4 H2 times 4 is 8 plus 2, then C4H10. And this is what you call butane. Okay. I can draw it to you if you want. So 1, 2, 3, 4. You have 1, 2, 3. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. So therefore, C4, C4H10. So that should be your alkane. And alkanes are basically your single bonds. This is are your alkanes. Now for the alkenes are your double bonds. Double bond carbon hydrogen compound. And in essence, these are also known as your sp2 hybridized. Now, to compute for the alkenes, we have CnH2n. And one example, we have 4 carbon, then we have C4H8. Okay? So this should be your butene. So depende kung nasaan. So we have butene. We have 2 butene, 3 butene. So we can check the formula. We have 1, 2, 3, 4. So this is your butene. So you have 1 hydrogen, 2 hydrogen, 3 hydrogen. We have 1, 2, 1, 2, 3, 4, 5, 6, 7. Okay, good. 1, 2, 3, 4, 5, 6, 7, 8. So we have 8 hydrogen for your butane. Butene, sorry. Next for alkenes. The alkynes now will now be considered as your triple bond. Your triple bond hydrocarbons. And in hybridization, this is the sp hybridized. And they have the formula of CnH2n minus 2. And the example here is C4H6 or butane. Depende po kung nasaan po yung triple bond. So if we're going to draw 1, 2, 3, 1, 2, 1, 2, 3, 4. So we have carbon, we have one H, we have carbon, we have another C, we have 1, 2, 3, 4, 5, and 6. So we have butane here. So we have the alkyne here for this case. Now, based on the structure, the stronger covalent bond is on the sigma bond. Now, if you have a pi bond, the pi bond is basically weaker. And alkanes are more stable when it comes sa mga reactions natin. Alkenes and alkynes are sensitive because of the availability of the pi bond, and therefore, when there's a reaction that can occur, they can either change in color and change in component as the reaction goes by. Now, if we're going to use this one as the analysis for our hydrocarbons, now using a catalyst, two gaseous hydrocarbons X and Y were produced from eating hexane, the C6H14. The gases were individually tested with aqueous bromine. For X, aqueous bromine became colorless, while for Y, the reddish-brown color of aqueous bromine was retained. Which of the following best describes the identity of the two hydrocarbons? Now, the first hydrocarbon, the first idea here is we don't know the amount of carbon and hydrogen atoms. We don't care about that one since this is not given. Since this is not given, then we only have two choices left. But based on the situation, the Y for the X became colorless and the Y is just the same. Now, if that is the case, then which is more sensitive, X or Y? Now, since X became colorless after the reaction, while Y maintains the reddish-brown color of your bromine, which is retained, then X is more sensitive, as I said earlier, then X is the alkene, then Y is the alkane. Okay? Questions? Okay. Questions? Questions? Any violent reaction before we proceed? Okay, so other alipathics consider your ating alcohol, which contains the hydroxyl group. The hydroxyl group is your OH group. Now, ROH would be basically our example for the alcohol. Now, the primary is basically the carbon for the alcohol for the carbon group is located at the end of the formula or the end of the chemical, the structure of the chemical. And therefore, if the primary, therefore, we only are attached to one carbon. So this is an example of an alcohol, and this is what? This is known as your ethanol. So we have two carbon, then ethanol is the name for that one. Okay. Now what about this one? We have three carbon, then we have OH. Now, is this considered primary? Yes or no? Is this considered primary? Yes or no? No, this is what you call a secondary alcohol. Now, what I said earlier is that ethanol, it must be structured on the end of the chemical equation or the structure natin. But in this case, it's located in the middle of a two-carbon chain. And therefore, this is considered as a secondary alcohol. And in some form, this is what you call uh, 2-propyl alcohol. But 2-propanol, sorry, 2-propanol, or this is also known as isopropyl alcohol. Iso means it's in the middle. So it's in the middle. And this is isopropyl. But about tertiary? When you say tertiary, we have 1, 2, 3, 4. When a carbon is situated with two other or three sets of other carbon chain, and this is considered the OH group, then this is considered as a tertiary alcohol. Okay? This is considered as a tertiary alcohol. Then this is secondary since only two carbon chains are here and it's in the middle, then secondary. But for the ethanol, this is situated usually at the end or only one carbon is located with the OH group. And therefore, this is known as 1, 2, 3, 4. So this is considered as 2, 2-methyl propanol, 2-methyl isopropyl alcohol. Okay. Next, we have aldehyde and ketone. So the last part is we have a chain here, primary chain. We have a primary and secondary chain. For aldehyde, you have a CHO for the last. And for the ketone, we have the we have two primary and secondary chain that is connected with your CO group. Then one example here is the CCH, then O. So what do you call this? What do you call this chemical or substance? So we have aldehyde. So the aldehyde has a al at the end. So if we have two carbon for this name, then we will have ethanol. Okay, ethanol. For the ketone, we can't have two carbon here, so we have at least three. So we have C, C, and C, and we have a CO group. Then we have 1, 2, 3, then 1, 2, 1, 2, and 3. So what's the name of this one? The name of this one is what you call propanone. So this is a ketone, so ang dulo na to, or the end is going to be ONE, propanone. Okay? Now, which of the following is a primary alcohol? Now, again, if there's no number indicated in the nomenclature, which this means it's situated, it's either at the start or at the end of the structural formula. So which of the following is a primary alcohol? Letter A, B, C, or D? Letter C. Okay, good. That's good. So ethanol, when you draw ethanol, we have C, C, then OH. Then we have 1, 2, 3, 4, 5. So therefore, the OH group is situated at the end of the equation. Next, what is the classification of the carbon group that is bonded in the OH group in the methanol as shown above? So basically, this is the carbon group that we're talking about and the OH group. Now, is this the primary, secondary, or tertiary? So correct. So this is what you call your secondary alcohol. Not primary because this is not situated at the end, but this is what you call a secondary alcohol. Situated at the middle with two carbon chain located with your OH group. Okay? Questions so far? Sorry. Questions? Okay, next, we have the carboxylic acids. The carboxylic acids, we have an R group or R. We have a primary chain group here or the R group, then COOH. So if you have a C, C, COH, then we have a two carbon group, then this should be called as ethanoic acid. Ethanoic acid, like ito. Ethanoic or also known as acetic acid. Now, don't be confused with acetic acid. Now, vinegar is known as your acetic acid, but in reality, your vinegar or the vinegar that's being consumed by us is basically only 5 to 8% of acetic acid, although they consider acetic acid for vinegar in some form. Then we also have ethers and we have esters. So we have C, O, and C. So when you have ethers, what's the nomenclature for ethers? What's the nomenclature for ethers? So since we have an ethers for the ROR, then we also have what for esters. The difference for the nomenclature of ethers is that they are what to call your, what to call this one? Let me correct you on this one. We have OH. Okay, so basically for ethers and esters, don't be don't be confused by the way you want to do the nomenclature for ethers. So for example, we have a dimethyl ether. We have dimethyl. We have 1, 2, 3. So we have a dimethyl since we have a 2-methyl group here, dimethyl. Then we have the ether here. So don't be confused on how to use the word ether since we always use the word ether if you want to do a nomenclature for ether. But for esters, this one has a special name for esters. We have the O weight here. So we have ethanoate if you're going to have a carbon, then carbon, C, then OR. So if you have a COOR or CROC like this one, so we have a ethyl methanoate. So we have ethyl. So this is the double carbon. Then since we have a carbon here, then ethyl methanoate. Okay? So that's the name for your ester. O weight po yung dulo ng esters natin. Next, for the amines. For the amines naman, we have what you call the primary, secondary, and tertiary. You need to have a nitrogen group or the N group, nitrogen group for the amine. So pag sinabing primary amine or when you say primary amine, you have one nitrogen group, one carbon chain or the R group. Then for the secondary, you have two carbon group or two chains. Then tertiary, you have three carbon or R groups for your amines. Then other alipathics, we have haloalkanes that contains your halogens, your amides that contains the nitrogen and oxygen, and acyl halides that contains oxygen and your ating halogens. Halogens or halogens. And organic compounds based on the benzene ring. Now, the benzene ring is special based on the structure. Now, if you're going to draw the benzene ring, this is basically, sabi nga nila, as they said earlier, these are basically piatos. But don't forget that there are always double bonds here. Sir, if I may ask, our benzene ring can also be drawn like this. Yes. Sir, what are the other ways to draw the benzene ring? To draw the benzene ring in other forms, this is the structure. So don't be confused if you're going to see benzene rings like this. Why? This is because the double bonds here and the double bonds here are almost equivalent and they are what you call resonating. Now, if they are resonating, which means the double bonds can be transferred from one bond to another bond as long as they are alternating. As long as they are alternating. So as long as they are alternating, then they are resonating with each other. And the example for the benzene ring, it's actually easier for you to understand if you're going to have a halogens like your fluorine, chlorine, bromine, and iodine. Just get the name of the halogen, then add benzene, like fluorobenzene, chlorobenzene, bromobenzene, and iodobenzene. Now, toluene is added in some exams and cumene, but in some case, they don't add this one. Ethyl benzene is added in styrene. So take note, ethyl benzene is a single bond, styrene is a double bond ethyl. Okay? Orthosilane, metha, and para, you just need to know where's the location of your CH3 or your methyl group. If both methyl groups are on the opposite, then that's considered para. If both methyl groups are in one gap between each other, then that's meta. But if it's near to each other, then that's ortho. Ortho dikit, meta magkahiwalay, one seat apart, metha is opposite. Okay? Then phenol is added. Yes, kasama po siya. This is basically one of the usual experiment. Benzoic acid is basically carboxylic acid added sa benzene. Benzaldehyde, you just need to do you just need to familiarize with aldehyde, but acetophenone, not so much. Methyl benzoate, not so much. Anisole, not so much. Then aniline, yes, they sometimes add aniline. Then nitrobenzene, yes, they add questions on nitrobenzene. Benzonitrile, not so much. Benzamide, no. Benzene sulfonic, but they have naphthalene and anthracene. So if you remember, naphthalene was given earlier, and of course you have anthracene, which is another form of benzene ring with multiple rings. Okay, this is what you call polyaromatics. That's why someone said that, sir, yung po ba yung sa ipis or sa cockroach, it has a very strong smell. So naphthalene is one of your polyaromatics examples. Okay, now to answer the question, what's the name of the benzene ring derivative from above? So we stated earlier that we have uh, ethyl benzene. If a single bond is ethyl, then that's ethyl. Then the other one is if you have a double bonded ethyl, then that would be what you call letter A, styrene. Okay, good. Now, what about this one? What about the name of this one? Just to give you a brief example, what if you're going to be given this kind of example? What if you're given this example? So we have three nitro group. So that's nitrobenzene, but you have a toluene here. So what would be the name of this one? 2,4,6 trinitrotoluene. Okay? 2,4,6 trinitrotoluene. That's the name of this compound. Okay? So that's it. Do you have any questions? Do you have any questions? Anyone? Nomenclatures, not so much. Around 2 to 3 questions, but not too difficult for you to answer. Mostly the difficult ones, based on my experience and of course with other people that I've asked about, majority of the difficult questions is more on the analysis and more on the graphs, then computations, then concepts. Nomenclatures, you only have 2 to 3 questions. Like for example, the last questions, that's how they ask questions. Just to check if you're familiar with some. Like for example, ethyl methanoate. So which means the O weight is an ester group. Then ethyl and methyl, you just need to look for the ethyl and the methyl group. Then they're going to ask which compound shows the ethyl methyl, which compound shows the phenol, um, which of the following is a phenol compound, which of the following is styrene, yan. And of course, with the alkenes like those for the organic chemistry, which of the following will show you a reaction for alkenes? Those are how they ask questions, more on analysis. They don't usually give branch of chemistry. I suggest general chemistry. General chemistry. Based on my experience again and again with other people, you just need to study general chemistry 1 and 2 if you're from senior high books, then some college-based experiments that will be used for exam. For general chemistry, then organic, the nomenclatures are the most critical. But for example, I don't know if they're going to ask the questions on metabolic processes or reactions that will require the proton acceptors, neutron acceptors, or the proton acceptors mechanism. I'm not quite sure, but I believe they do not add that one. What else? Any questions? Any more? No, not necessarily. They do not include biochemistry. Biochemistry is far more difficult. Although they may ask regarding enzymes, but they will not let you compute for the enzyme part. It's mostly on thermodynamics, basic thermodynamics, but it's mostly enthalpy and tsaka entropy. Any more? Okay, so that's it. So thank you very much for attending for this morning session, and I hope you do well on your end month exam. And please review more and make sure to study. And don't memorize, guys. Try to understand the questions and how they ask questions so that they won't be confused on how you want to analyze them. Thank you, guys, and good morning to everyone.